I should be making a video, even though the icon doesn't change, which really sucks. Another crappy feature of Linux. I meant this 20 thing just absolutely sucks. I guess I have to make a Linux video. So sorry about that, but yeah, I've done it in the past, and I'll do a couple of those maybe. This is terrible. They did an update. It takes, almost 2 minutes to boot. You can't suspend it or hibernate it. I mean, it's just a piece of shit. And, you waste my time configuring and going through all this crap and loading the programs that I need to use, and it's not even worth the trouble. And I might as well go back to 19 or 18 even. Works better. So, disappointing. I mean, it hasn't crashed yet, but I haven't used it yet either. But I mean, little things, just, it's like, why did they break that? How did they break that? That should be able to work. I mean, come on. Having an icon that shows that it's recording is kind of important. It should work. It just doesn't. Ugh. Anyway. It's just too irritating. So, anyway, we'll move on. I'll try to get over it. Well, it's not useful. That's not useful. Well, that one might be. Alright, so comments. We'll do some of those, and then do some Silence Asylum, I guess, or something. It's going to be on sort of relativity and shit like that, but it's all related to photons, so something like that. Force and matter, and the fact that they have no, conventional physics is just junk. It's all wrong, frankly. I mean, all of it. It's just all of it is garbage. The 400 different particles, the whole thing is stupid. Gluons, all of this crap they've invented that have no role to play really. No sensible one. Just horrible nonsense. Spin, Heisenberg, superposition, entanglement, it's all nonsense. And I've demonstrated that their foundational experiments, like the two-slit, have been completely butchered. Their understanding is completely wrong. Their math is wrong. The whole thing doesn't fit. It doesn't work. Their story has huge, gigantic holes in it. It takes some work to find them and to expose them, because they've had 100 years to sit there and create this fake facade. And so, it looks like something, but it's really nothing. It's just junk. And the fact that none of these people, nobody will concede. I mean, one of my critics by now should have showed up in the comments and said something like, well, you raised some good points. Can't get around it. There are mistakes. There are errors. This is sort of, it shouldn't be this vulnerable to dissection, where the parts aren't where they say they are, and, the thing isn't what they say it is. But no, not even a single concession. And so anyway, the whole thing is just quite depressing and blah, 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 blah. So some guy says, if you have clear knowledge, bro, so you obviously have no knowledge of me, because then you would know that I really don't do this bro crap, or this dude crap, or any of that crap. Alright, save that for your mother-in-law or something. I mean, save it for somebody who enjoys being patronized, because I don't. I'm not your bro. I'm not your dude. I'm not your slave. I'm not your lesser. I'm not any of that crap. And that's what all that rhetoric basically is saying. You might as well just say boy. Anyway, you either get it or you don't. Well, that's just too fucking brilliant. The whole point of making thousands of videos is that getting it does take some work, and you do have to explain and all that kind of crap. And it's not just getting it or you don't. I mean, you don't say that about something like 2 + 2, or me, equaling 4, or something, mechanical. You say that, there are rules to logic and facts and ways of, just acknowledging things like the difference between something that has a lot of evidence in support of it and something that has very little evidence. I mean, those are simple things that if people can't even do that right, they can't be honest about the strength of evidence, we're doomed. Doomed anyway, but and if you don't, maybe you're not meant to. I mean, it's just too stupid. And then he says this peace crap, whatever the fuck use that is. Peace. Fuck you. Food. Water. Balloon. I mean, should I end all of my correspondence with somebody with some random silly word? Angel. Fluffy kitty. Fluffy kitty to you. I just hate people. I have no use for whatever that crap is as a piece of communication. It's logically vacuous. It doesn't say anything. Oh, if they can't be convinced, they can't be convinced. No, it's not how it works. You have to make better arguments then. That's the obligation of the persuader. But yeah, you can't do much about dishonesty, and that's what it appears that is the underlying problem. This isn't about the facts or the truth. It's about, your hair's too long. You're too pretty. Some kind of crap. Anyway, so then Masterpool chimes in with, the TV advantages pretending to be a faith healer was Peter Popoff. Well, yes, he was found by James Randi, and he has to provide a link. I mean, look, it's just a reference to a phenomenon that happens where people are shown to be fakes and phonies. You really don't need all this detail. There's been lots of debunking of fake evangelists, okay? This is not the moment in history where we all figured it out. I mean, come on. I'm sorry, but I don't need that shit either. Then Dove says some crap about trolls, which is nice. And then Tween Two is also blah, 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 but not really on a subject of any kind. So how do you explain global cooling in the 70s? So the truthers just can't let it go. First of all, the 70s was 50 years ago, and it was sort of the peak. We had really exploited the Industrial Revolution, and we were only 50 years into it, so to speak, into really pumping the crud into the atmosphere, and especially the third world. They were barely beginning. China and all those places were barely starting in the 70s. And there was no global cooling in any dramatic sense. I mean, every year there weren't record cold temperatures and all of that kind of stuff. So, I mean, I lived in the 70s. It wasn't Antarctica. So that's just sort of, And obviously nothing starts or stops instantaneously. So the moment you put a little extra carbon dioxide into the atmosphere, it doesn't change all the cycles of the planet, the next day. And everybody knows that. So you're just looking for a reason not to believe the obvious. What is plainly obvious is that we've taken a bunch of carbon that was stored, that was out of the atmosphere, out of the biosphere, and we've put it back in. Is that or is that not a truth? Fuckhead. I mean, it's just too stupid. Are we or are we not going back to a previous state? I mean, shit. Okay, but no, just do what you have to do. You have to not believe. Okay, go ahead and not believe. It doesn't matter how much oil you burn. It doesn't matter how much carbon dioxide. It doesn't matter how much how much coal or anything else you throw back into the active biosphere. It just doesn't matter. Fuck. Alright, I appreciate your content of your videos, concepts presented, so-called experts. I would be interested in your opinion of the presentation as it relates to gravity's influence on photons. Well, it's kind of boring. Okay, so it's some Indian guy, and he's doing this silly the silly idea that you can apply gravity formulas to photons, that somehow photons do have a mass, and that he's basing its mass on its frequency, which isn't really the right way to do it, because if you want to be honest to Einstein said photons are twice as affected by gravity than everything else. So you can't use a standard momentum formula, because you have to apply the fact that photons are twice as affected by gravity. So it doesn't even make any sense. But it's just basically saying what goes up comes down. Even photons are slowed down, but their energy, the slowdown in their momentum is in the form of shift in their phase, their frequency. And that's just crap anyway. And then it counters the whole theory that space is expanding and that's causing redshift. And so if you start saying that every time a photon travels through space, every gravitational influence is degrading its frequency, it doesn't make much sense. It very quickly becomes nonsensical. So I would just say it's clearly nonsensical to understand photons as objects that are affected by gravity. It just breaks the whole universal theory kind of thing, the whole relationship between forces and matter. The default is you need really good evidence to overcome that default evidence that forces aren't affected by forces, and breaking that default, breaking that something that appears to be proven by every single experiment except for two, that kind of thing. The odds are the two experiments are fooling you, and the two experiments would be your Hubble telescope crappy images of gravitational lensing which never look right, and the Eddington experiment, and that's all you've got, and those are both crappy pieces of evidence. Alright, so related to that, sort of. I'm not going to play that video just because it's kind of boring and there isn't much information in it. It's just based on this idea that somehow photons have a mass that's related to their, they have a mass, but there's no way to say it really. There's no way to make it rational, because at one minute they're saying it's a massless particle, but then it has enough mass as it relates to its velocity that you can put it into the equation, because they've converted frequency into momentum. And so if to have momentum, you have to have a mass. So they end up turning the frequency into mass and velocity. So I guess you could just make up the mass would be 1 and just make its velocity its mass, which is just stupid. Alright, anyway. Ooh, cold, sorry, a little shivery. Shivery. Alright. So, yeah, I'll probably go back to the live crappy thing. the crappy live version of Linux that was like written 10 years ago, because it works better than this shit. They really did. When you fuck something up and it takes twice as long to boot, and you can't suspend or hibernate. Those are kind of basic functions. When those are broken, fuck. You're not going in the right direction. And your icon doesn't even change. Shit, that's really annoying. When I don't know that it's recording, that's really fucking annoying. Okay, anyway. So, on to this video.
Hey, crazies. We're made of matter, which means we experience time. But what if we weren't made of matter?
So let's understand what time is. Time, so for them, they think time is some confusing thing. But everything in the universe is based on one kind of standard for time. And the standard is you have to do something slower than instantaneous. So the fact is that force or energy moves in the universe at something less than instantaneous. It can't change its position instantaneously. So nothing gets from one point to another point. Now, let's just exclude entanglement, okay, because we know that's crap. So let's see if we can put this in some kind of position that actually works for both of us. Fucking screen hog. You go from point A to point B. Look at that, you can see it. All right, and it takes a certain amount of time. Now, the fastest you can go is the speed of light, 300,000 meters per second. And you go from point A to point B, and the distance is going to dictate how long that'll take, and that's what time is. So time is just the fact that the force, the fastest stuff in the universe, doesn't get instantaneously from one place to another. It takes time to get to another place. And so everything's running on that cycle. You could argue change in the universe. Okay, so the universe looks a certain way. Things are in certain positions. And you can know that for them to change positions, it's going to take time for them to change positions. And the time is going to be on some scale, like how many of these seconds, the time it takes a photon to go from, New York to Pennsylvania or whatever. And you just say that's the standard, and you just count how many bits of time it takes for matter to move. And I'm just saying there's one clock in the universe, and it's the speed of light. And that's all you need. And then you know what time is. Time is the fact that energy can't get from point A to point B instantaneously. It takes it a certain amount of, it has legs and it has a certain walking speed, and that's time.
What if we were made of something timeless, like light instead? What would the universe be like for us?
So he just says it's timeless when it's obviously not timeless. It's got the same problem. So if you were doing the Einstein thing and saying, well, what if I was a beam of light? Okay, here I am, little beam of light guy. And, I was traveling through the universe. Well, it takes time for you to travel across the universe. So you could say if the universe was 13 billion light years across or something, it would take you 13 billion light years to sit there and travel across the universe. And yes, as you're traveling, everything's going to go by you really fast because you're moving pretty damn fast, but you're still moving slow. Compared to instantaneous. Compared to instantaneous, you're going really fucking slow. But yeah, you're going a lot faster than we are going, so everything's going to buzz by pretty quickly. You're not going to get too many photons from too many sources. Everything's going to be pretty faded and pretty blurry.
This episode was made possible by generous supporters on Patreon. Okay.
Stupid bastards. So, I mean, I wish I could communicate with these people and just, why? Why are you supporting this garbage? All right? They really isn't doing anything good for humanity here. Just propagandizing for this silly fable. Oy.
Stuff in the universe generally falls into two major categories. Matter and light.
There, you got it wrong again, okay? So yes, the matter part you got right. And matter, it just means electrons and protons. That's it. Two things, okay? Electrons, protons. They're the only significant players. Neutrons are just a combination of those two things. They're the elemental bits of matter. And they get moved around by a force. The force hits them and they move a place. And when they do that, they take a little bit of energy out of the force. The force is moving C when it's moving the matter bit. That is when it's pushing it along. And the matter bit moves to this new location. It moves at less than C. Okay, so now the force occupied moving the matter, while it's doing so, it's not going the speed of light anymore. So it's, it's got less energy. Total energy, its total energy has declined. It was this, and now it's only this arrow, in terms of what it's accomplishing in the universe. And that's your cause of gravity. So every time an electron or a proton moves, it's moved by force, and when it's being moved by a force, it's absorbing the force's, a piece of the force's energy, and that's creating the idea of attraction and repulsion.
What separates?
So there's matter and force. So I didn't get to that. So that's the matter part and the force bit. Force is just in the form, F-O-R-C-E, The force is just in the form of a bit. And the fact is, it's just like you have two kinds of matter. You actually have two kinds of force, okay? The plus reflective and the, you could call it the minus reflective, in the sense that there's two interactions. The interactions are, I reflect you eventually, okay, or I divert you as a force. And that's the two reactions. This one has a change in momentum. This one creates no change in momentum. With those two interactions and these two forces and these two forms of matter, everything can be explained. All the attraction and repulsion, and it's all communicated. There's no force carriers. There's force. Force doesn't travel in a Volkswagen to get to a location. The force is the Volkswagen. The force is the thing, and you either hit something, okay, with force that moves it, or you don't. A lack of force is the same thing as a, it's just as much of a change as the excessive force. Low pressure is the same as high pressure in terms of its ability to cause change in where the matter is going to go. So anyway, that simple thing explains it. So this is where they go wrong. Like, just by calling it the speed of light, again, I can make this simple request. If you do nothing else, you physics people, you should at least be able to agree it would be better to call it the speed of force, right? Speed of force than speed of light. Because all the forces move at that speed. All of them. And light is just a form of the force.
Is the rest mass.
All right, a stupid concept of talking about something having rest mass when it can't mean anything in a universe where you just have dead matter. Okay, so let's understand the electrons and the protons don't do anything until they're told to do it by a force. A force has to hit them. So if there's two force bits coming this way, the matter bit's going to end up going this way. That kind of thing. It's just that simple. So matter does nothing until it's forced to do it. All right, and so that's all there is to it. But there's no rest mass. Obviously, something is measuring. If you're measuring mass in a sense, like gravity does, gravity is just telling you there's more pressure on the outside. There's more stuff hitting me coming down than there is coming from the bottom. So if I was a person, I can sense that as an understanding. I can say, okay, I get this, right? If there's more stuff coming down this way than it's coming up this way, right? There's only 3 coming up and there's 4 coming down, then I'm going to be net, this way. And that's what happens to things when they move. So when you move matter, you're creating a change in force because you're consuming it to move it. You're consuming a little bit of its energy. So the stuff, obviously if I move towards you, it means I absorbed force going this way. That means there's less force coming this way at me, right? Because I absorbed some energy to move. That means there's less energy, and that means I'm going to be gravitational now to something else because I'm going to stop energy from hitting it, just like the Earth stops energy from getting to you because it's busy moving a bunch of little pieces of the Earth. That's no other way of saying it. So movement, okay, creates mass. The more stuff moving. So anything that's going to, and everything's in this one universe. So that's the other thing everybody should agree on. There's only one universe, and it's the little one. Okay, the one with the electrons and protons in it. That's the only universe. Everything happens there first, here later.
Has it, light doesn't.
Alright, so obviously light is a force. It has momentum. It transfers its momentum. It hits something, and again, like I say, it's going the speed of light. It stops going the speed of light now because it's got to push the matter. So it's going less than the speed of light when it's pushing the matter. Obviously, there's been a reduction in the force on this side of the universe versus this side of the universe, right? Because this piece of matter has taken a force out of the game for a little while.
But categorizing things by their mass can be problematic, because mass is not a fundamental property.
So it's correct. Mass is not a fundamental property. The fundamental property is the ping pong paddle argument, I could argue, right? You know, you put two ping pong paddles and you have a ball bouncing between them. You can sort of understand that the force, the amount of force in here, changes just by changing the distance between the paddles. I make the paddles closer, there's more force, there's more reflections. You know, they hit more often, more interactions. But the trick is, to move the paddles, I have to apply more force. So that's where the conservation comes in. There's no way to move the paddles without applying a force to do it. And that force has to be stronger than the force increase you're creating. So you have to create more pressure, high pressure on the outside of the paddles to create the high pressure on the inside of the paddles. So you can't get high pressure without applying a pressure. And yeah, so that's all that needs to be said. So you could think, again, you can go for a little further and speculate about the whole universe. And you could just say the universe was a bubble. You could kind of understand, okay, that if the matter is getting closer together and it's trapping force, little bits are trapping more and more force, it's getting trapped, moving matter, jiggling it, that there'd be less force out here then, you know. So let's say the force reflected off the walls and just bounced back. So it's conservational. Well, then you sort of know that the matter, the more force that gets trapped inside of here, the less force there's going to be out here. And that means the gravitational constant would change with time. And you could just sort of understand that there's just a tug of war. And you sort of have some evidence for that, in the sense that galaxies that are old, we call them quasars, they're small and more, they're generating more light, so they're hotter, even though they're smaller. So it sort of indicates that they have expanded with time, and in expanding with time, they've released some energy, okay, and that energy now is creating more gravity, and the gravity will eventually make them small again, and they just go back and forth between being contracted and expanded by leaking the energy out. Then the energy's back in here. Eventually it's going to come back and push it back in again. So the gravitational constant just changes. Goes up a little, goes down a little, goes up a little, goes down a little.
It's an emergent property. It appears out of the interactions between particles.
So that part is good. You know, it's good that somebody says that's all that this is about, is just the fact that I've just, like I said, I changed the energy of the universe by just moving two things closer together. I can trap force, and by moving two things to the right kind of things together, I can also release force. So like a neutron, which is an electron and a proton, I could take an electron and a proton and just make them different size, and then another proton, and I can create a circumstance where all the energy leaks out, and so nothing gets trapped between anything, and then you can bring protons very close to each other. Yeah, lots of scenarios, but it's just the energy is the little bits of force, and you can label them magnetism, or you can label them light, or you can label them gravity, but it's all one thing. It's stuff moving the speed of light.
Out of the ensemble. Seriously, consider something extreme like a black hole.
Right, so you know, you can consider things extreme, like I just drew a neutron, and I could say that, okay, that a regular matter, an electron and a proton, could be taking up space in the universe, and they can have a certain distance. But if I can reduce the amount of distance between them, that is, I can take an electron and a proton, and then I can have another proton, and I could have another electron. I could arrange matter like in a neutron star, where I have all of these things arranged so tightly that the matter only takes up this much volume, and contains very little energy, right? Because I've taken all the pluses and minuses, all the energy that comes in goes back out again rather efficiently. There's very little jiggling going on. And you could say that's a neutron star, is this arrangement where you take all the electrons and protons, a lot of what would be mass, and you end up making it very efficient in how much space it occupies and how much energy gets trapped between it. Okay, you're kind of evading all of that. But this idea of a black hole where the electrons and the protons are all on top of each other in the same little tiny space is a preposterous notion. You can't do that. You can understand arranging matter efficiently, so you can make you can take a lot of electrons and protons and put them in a small atom, so to speak. Where you have a more efficient atom, an atom that's where the spacing is such a way, the arrangement of magnets even. You can arrange them so that they're very efficient, but if you have them all going in different directions, they'll take up a lot more space than if you put them in a place, an arrangement where they're not in all different directions, that kind of thing. You can just understand they'll occupy less space when they have compliant geometry. So neutron star makes sense. Black hole, no sense.
Probably heard of black holes eating entire stars. But they don't just eat matter, they also eat light.
So that's what they say, right? And they don't really have any evidence for that, so they just say it. The evidence that black holes eat light, that they have enough gravity to bend light, and again, even the very fact that light is bent by gravity, it's a critical statement. I mean, it's, they've turned it into something really important in the sense of all the stories they tell that they build on top of it. I'm saying all those stories are irrelevant. All of this black hole science it won't even make a good candy bar. They'll never make anything out of it. It's never going to be relevant to our existence in any way. It's just part of their storytelling. It'll change what can happen in movies. It's not going to change what happens anywhere else. It's just fluff and irrelevant. So it's not very important. But as a concept, it's really important to understand what a photon is, and it's not what they think it is.
Light is massless, but if a black hole eats some, it'll still grow.
So obviously that comes from some notion that yes, if you put force inside of an arrangement of matter and the force doesn't come back out, it's stuck in here doing this, jiggling the matter, then the force is obviously occupied. It's not, its energy is in here now. And it's not out here doing anything. Okay, so I mean, it's just understanding. I mean, if you make a force travel in a cul-de-sac, you just trap it in the cul-de-sac and it just goes around and around and around. Well, obviously you've taken energy out of the universe, so something significant has happened.
The light has become massive just because it's trapped.
That's the idea. If they understood traps, they would understand physics, because that's all it's really about, is trapping force and untrapping it. And that's all you're doing. You're releasing it or trapping it. And that's what matter does. And it traps it in small packages or big package, it just depends on the circumstance. But it's just about taking the energy out of the force by forcing the force to have an interaction. When the force interacts with matter, again, it consumes its energy for a period of time. It reduces its influence in the universe because it's not going where it would be. It would be here, and it's not going to be there because it's stuck moving the piece of matter. I mean, the concept is so simple.
Confinement. Mass emerges from that confinement.
Yes. Gravity emerges from it, and that's what we're associating with mass. So when you move matter, okay, it consumes force, which means you created gravity, and therefore you think it has mass. It still doesn't have any mass, it just has force. It has force it's occupying. So the more force it can collect, let's say it collects a bit of force, it gets hit by one piece and then gets hit by another piece in the same direction and gets hit by another piece in the same direction before it gets hit by any opposing force to negate that, it can collect quite a bit of energy. And that's what a muon is, for example, or some other piece of charged energy. Any charge that's moving is moving because there's energy pushing it.
For that matter, you don't even need the black hole to begin with. If you get enough light in one place, it'll become a black hole all by...
Right, see, more silliness. So obviously you can't trap light without matter to trap it. So the only trap you can make has to be made out of matter. Matter reflects. Okay, let's understand it. Force either reflects or is diverted. Those are the two choices. If it reflects in time. It reflects because it gets hit with an opposite force, and that's when it reflects. It doesn't reflect immediately. So it moves something until it hits another force, and then it stops moving it, like a pool ball or something else. It is very kinetic. But if it's diverted, there's no exchange of momentum. The force is just changed in terms of what dimension it's in. So those are the two interactions. Again, two kinds of force, two kinds of matter, two kinds of interactions, and the whole thing is dissectable.
Itself. It's called a Kugelblitz.
So isn't that silly?
Ball of light. A massless ball made entirely of massless things.
Right, so this is just baby talk, right? This is just some fake, phony bullshit thing. You can't do this anywhere. You never can. You never will. You'll never make anything called a light ball. It's just silly talk.
And a similar thing actually happens inside your body.
No, it really doesn't.
Almost all of your mass comes from the protons and neutrons at the center of your atoms.
Yeah, where your mass comes from, and again, that's kind of wrong because it comes from whatever jiggles the most. So you could argue that the mass, even though there's a lot of weight in the sense that if you take the pieces out of, if you take the individual bits, like the neutrons and the protons, out of the nucleus as individual bits, well, then they're going to be jiggling a lot. But the very fact is there are an arrangement that makes them more stable in the nucleus, so they're not jiggling nearly as much. So the fact is the little tiny electron, even though it's got less separate mass, independent mass. See, instead of having an idea like rest mass, they ought to have an idea like mass independent, okay, of circumstances, arrangements with other things. Because then everything has zero mass, in a sense. It just has the mass that the universe creates by moving it every millisecond. Every Planck moment of time, let's just say there's an amount of force hitting it. Obviously there can be some understanding. I could run the frame rate slow enough where I would see each little bit of force hit, and each little bit. And so this is happening like every gazillionth of a second. A little bit of force is hitting, but it's each one is doing it. And so at each moment, all right, this thing is moving somewhere else. It's moving somewhere else. It's moving somewhere else. And it's that movement that's creating gravity, that's absorbing the energy of the force. So every time something's moving, it means it's absorbing some force. So that's the key to creating gravity, which is the key to identifying mass. The nucleus is, we've taken a lot of that movement out because now the forces are getting diverted, substantially. And so stuff goes in, it just goes out, and it goes in and goes out. It doesn't move anything. Without moving anything, there's no mass. So even though the nucleus seems massive, it's really not. It's charged, it's magnetic, but it isn't got any substantial, it's got less mass than its components because of the way the components are so well arranged. Just like a magnet can create gravity, even though it's not doing anything. Nothing's moving to create the gravity, nothing's changing, it doesn't get hot, it doesn't do any of this stuff to create this force. Because of its arrangement, its efficient arrangement means that it can do something that looks like it's using energy, but it's really not. So anyway, the point is the small electron jiggles a lot because it's out here by itself in this field, constantly bombarded and constantly moving all over the place. And so it's absorbing more force than the nucleus, which isn't moving as much.
About 99% of that mass is from massless gluons.
Right, so gluons are just fake, phony, not real, no such thing, blah, 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 blah. They just said they're massless. You can't absorb a gluon, you know, you can't take it out of the universe, you can't change the energy potential with a gluon. You have to do it by having something that has a real force bit. A piece of force has to move the matter for you to absorb its energy and create gravity, which is your definition of mass.
Just because they're confined to a space about 1 femtometer wide. My point is that you're already made of massless particles.
Right, you're already full of a bunch of photons, energy, force bits, okay, potential photons. Look, the argument is that if you have these little energy bits, these little force bits, okay, these little pieces of momentum that travel the speed of light, and you put them at a constant frequency, that's a photon. If I segregate them for electron force, so let's say electron force, we'll put an X, you know, they have an X in them. You know, if I separate, and the photon's light is made out of the electron force. But if I segregate this force arrows, they're all coming from all directions, so you can just think of them as red and blue. And if I segregate them, you know, take the purple and turn it into red and blue, that is, I make the proton relevant energy go one way and the electron energy go another way, then I create a magnet. That's magnetism. And gravity is just the purple. It's both, affecting both the electrons and protons in an inverse manner. The red force makes a proton do nothing. The blue force gives it momentum. You know, this is the rule. Simple rule.
Gluons. Making you out of massless photons instead wouldn't make much difference. If they're confined,
well, again, you can't make something out of them. You can't keep them in the container, okay, without something to keep them in the container. Unlike a fish, they can't just change direction. They can't turn, okay? They can't stay in a circle. They have to be forced into a circle or forced into a square. They have to be forced into a cul-de-sac made out of matter. They have to be trapped by matter.
Will still have mass, which means you'll still experience time the same way.
So again, everything experiences time the same way, and it never changes, and that's just more of bullshit. So again, let's just understand why they think of this time dilation thing is because they really don't understand radioactive decay. So the key is that when decay doesn't happen, you know, I had, you know, like everybody else, you wonder, based on what they say, that you'd say, okay, this atom is 10 days old, and so it has a decay rate of 10,000 years, every 10,000 years, so it's really young, it'll last a long time, it's durable, blah, blah, blah. So I kind of thought originally decay had something to do with the atom actually decaying, and that is it got old and it fell apart. Like there was some little tiny orbital problem, like Mercury's precession. And every 10,000 years, the precession does something too stupid and the atom breaks. So that model of decay is wrong. The decay doesn't happen from inside the atom. Okay, the decay happens for like a Star Wars reason, where a special circumstance happens where, let's just say, force has to come in at exactly the same moment and hit the one proton. So it has to get hit simultaneously by two pieces of force at exactly the same instant. And then that causes the chain reaction that just breaks the whole frickin' atom. So you could sort of understand that some event could trigger it. And we can sort of understand that it must be that way, because if I put decayable atoms close to each other, they decay more. Okay, so in spite of the fact that people say, oh, it has a half-life of 5,000 years. Not if I put a bunch of it close together, then all of a sudden its half-life is 100 years. So they start decaying a lot faster if I put them in close proximity. So when they say decay rate, they mean in some sort of standard volume or standard distance from each other or something. But the closer I bring all those radioactive elements, the more and quicker they decay. So we know that decay is something that's environmental. And the environment decides how fast something decays. It's a contributor to the decay rate, which means it's probably the cause is the point. So the fact that it's contributing to decay rate probably can mean it's the cause of decay rate. That's the logic here. And so the idea would be is if you're moving this decayable atom, however you want to draw the atom, and I move it, well, if it's the environmental circumstances, it has to be hit with the same amount of energy, an instantaneous event, not instantaneous, a simultaneous event has to take place. Well, you could sort of understand if I'm moving it, I'm going to get more of this, and I'm going to get a lot less of this. The faster I move it, the less of this I get. This arrow gets smaller and smaller and smaller. So if I move it quickly, then I change the probability of this meeting this. So the faster I move it in a direction, the less likely this becomes because I hit more arrows in one direction and less in this direction, and that means the odds of this simultaneous event become lower and lower and lower and lower and lower. And that could be what's extending the decay rate of the atom. So when you move U, the argument is atoms have a structure, and the structure is dependent on a bunch of force moving around inside of it. And obviously, just like a school of fish, if I move the school of fish, right, the school of fish has a balance, of fish going this way, fish going this way, fish going this way, fish going this way, right? And you could just see the school is just sitting there. You see the fish are moving, so you know they have to be moving in all kinds of different directions, and it all comes out to equaling nothing, 0, right? But if I move it, it means, well, I have to take away some of these fish and add more fish this way. And the faster I want that school to go, the more of these fish I have to eliminate, and the more of these fish I have to add. And so you can sort of see that your body would never be able to be transported any kind of fast speed because all of the bits inside of you would have to be going the same way. Everything would have to be, all the force would be going in one direction. And if you're getting close to the speed of light, it means you'd essentially have to be made out of force because you wouldn't be able to push matter anymore because matter's always heavy. It takes energy to move it. And so you can't achieve that speed and still have electrons and protons. You'd have to get rid of the electrons and protons because they're slowing you down. So you really couldn't be made out of electrons and protons anymore. And, that's this. They tell you this isn't true. There isn't any real speed implications. There's no, you can just speed up these atoms are just, They really believe that you can just move the things any speed you want to, and it'll have no effect on the physical structure of the atoms, which have to, they have your atoms right now are doing certain movements in certain directions, okay? Like this fish in the school, they're doing something, and you can't undo what they're doing and still have a structure. So if you're going to break the traps by moving it too fast, you're not going to be a material thing anymore. Your matter is going to fall apart, and that's the truth of it. So that all of this is just this is just wild speculation. This isn't science.
Yeah, but what if those millions of photons aren't confined? Then you're not a single object. Okay, then what if I'm made of a single photon?
Yeah, so this was just stupid. So now it's just, well, let's pretend in some ludicrous state where we don't have to obey any of the rules of matter and motion and velocity and momentum. So we'll just forget about it. And now we'll just do this silly thing, what if I was driving a photon? And they're still going to make up a story that doesn't make any sense. Even if you're driving a photon, it's still going to take you 13 billion light years. It's going to take you a long time to get from one side of the universe to the other side of the universe. Your car still has a speed limit. And it won't, that's not changing. The fact is you can't age in any kind of way because you don't have any matter to age. Yeah, so... But the clock in the universe is still ticking. If I have the clock's universe sitting there telling you how many seconds passed, the same number, 13 billion light years worth of seconds, will click on the clock. You'll watch that happen. The clock hands will move. So anyway, the rest of this video is absolutely useless. So anyway, we'll call that a video. I gave you some of the pieces. Obviously I can go into greater detail in all those elements than I have in previous videos and blah 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 blah. But the truth is they have all of this wrong. Just all of it. I wish I could say that they have something that makes sense, but they've broken momentum by calling it frequency. They don't understand tipping points. They don't understand that something can have more of an effect depending on the circumstance. It's just terrible science. And anyway, we'll call it a video. I'll have to do this, I suppose, to make sure something doesn't go wrong and such. So hopefully we have the first video and maybe the last one on Linux Mint 20, which is a pile of shit so far. All these updates suck. I can't get over how bad the Firefox update on the tablet is. Maybe it does something on a phone that makes sense, but it doesn't do anything on a tablet that makes sense. It's the shittiest web browser in the universe. Can't find anything, can't get to anything, you can't even do a bookmark, you can't even bookmarks, nothing. It's just so fucking bad. Takes forever to load, and I don't know how they could break something so substantially and call it an improvement. Ugh. So it's just if that's the trend, it's just very depressing. That I somehow have to have a bunch of archaic, unupdated stuff. They're like forcing me to live in the past. Shit.